Welcome to Lucid Mind Chemistry channel. I'm Majid and in today's video I'll be solving O-Levels Alternative to Practical Paper 41 from October-November 2020. You can go to any specific question by following timestamps given in the video description. Let's start solving.
Question number 1. A student wants to separate a mixture of dyes so that the dyes in the mixture can be identified. The apparatus the student uses is shown. The student also tests dyes A, B, C and D. This is the apparatus that is used. We have lead beaker, paper is immersed in the solvent, and there is a baseline upon which the A, B, C and D are present, and there is also a mixture of dyes. Part A. Name the process the student uses to separate the mixture of dyes. The experiment that is shown is called chromatography. Part B. The apparatus shown in the diagram is set up incorrectly. Explain why. As in the experiment, we can see that the substance A, B, C and D are below the solvent line. So what will happen that this will dissolve in the solvent rather than getting up in the paper and being separated. So the problem with the experiment is that the solvent level is above baseline. The solvent level should be below baseline A, B, C and D. The apparatus is then set up correctly. The solvent travels up the paper is removed and then dried. The result is shown in the diagram. Now this is the diagram in which we have a baseline, paper and solvent front is given. See which of the dyes A, B, C and D are present in the mixture of dyes. We can see that the mixture of dyes has been separated into these components. Let's look at A. For A we have this spot, and we can see that this spot is at the same level as compared to the mixture of dyes spot. So A is present in the mixture of dyes. For B we can see that this is the spot and this is also at the same height as compared to the mixture of dyes. So B is also present. For C we can see that the spot is this one, which is also at the same height as compared to one of the mixture of dyes spot. So C is correct. For D we can see that this is the given spot and there is no spot in the mixture of dyes that is of the same height as compared to D. So we can say that only A, B and C is present in the mixture of dyes. Part D. The student identifies the dyes in the mixture of dyes using RF values. Measure the distance between the baseline and the solvent front, the baseline in the position of A. This is the given baseline and the distance from the baseline to the solvent front is this much and it is about 6 cm. This is the distance that is traveled by component A and it is about 1.5 centimeters. So with the solvent front we can write 6 centimeters and with position of A we can write 1.5 centimeters. Part 2. Calculate the RF value of A. Now the formula for retention factor is the distance traveled by solute, distance traveled by spot A divided by the distance traveled by solvent. Or in other words, it should be solvent front. By putting values, we have 1.5 cm divided by 6 cm. By dividing, the RF value comes equal to 0.25 and there are no units. Question 2. When metal carbonates are heated, they decompose and give off a gas that turns lime water milky. A student investigates the rate of decomposition of 4 metal carbonates using the apparatus shown. This is a metal carbonate and it is heated. It decomposes to give a gas that turns lime water milky. The student separately heats each of the metal carbonates with a Bunsen burner, measures the time taken for the lime water to turn milky. The results are shown in the table. This is the results. We can see that 500 seconds have been taken by calcium carbonate, 120 seconds by lead 2 carbonate, 300 seconds by magnesium carbonate and 205 seconds for zinc carbonate. A. Name the gas that turns lime water milky. We just have to write the name. Now you should know that carbonate decomposes to produce carbon dioxide gas under heat. And carbon dioxide, it turns lime water, which is calcium hydroxide, into milky water, which is due to presence of calcium carbonate. So the name of gas is carbon dioxide. Part B. The amount of heat supplied by Bunsen burner must be controlled in each experiment. Suggest 2 ways in which the heat supplied by Bunsen burner is kept constant. We can do this in a number of ways, such as the strength of flame should be same. We can also write same height of flame. Or same intensity of flame that is used. This is because if the strength or height or intensity of flame is unequal in different experiments, then the experiment is ambiguous. Part 2 suggests 2 other variables that must be controlled. Now, apart from the intensity of the flame or the heat provided, 2 other things that can alter the rate of reactions are same amount of solid used, or we can say that same surface area of solid. This is because if different amount of solid is used, then the rate of reaction will be variable. Similarly, surface area also alters the rate of chemical reaction. Second thing used in the experiment is lime water, so the concentration or volume of lime water should be same. If different concentration or volume of lime water is used in each experiment, so then what will happen that the time taken will be different and the results will be inaccurate. C. Which metal carbonate is the slowest to decompose? Now we can see that this metal carbonate will be the one which is taking greatest time to turn lime water to milky. In the given table, we can see that calcium carbonate takes 500 seconds to turn lime water to turn milky, while the others take less time than this one. So it means calcium carbonate decomposition is most difficult, or it is the slowest. So the answer is calcium carbonate. D. Suggest how the investigation can be improved to make the results more reliable. Now this can be done by repeating experiments. And after repetition of experiment, we can take the average or we can also use consistent results. This means that we should take the values that are closer together. Question 3. A student provides with dilute sulfuric acid labeled L. The student determines the concentration of L by titration. The student uses apparatus A to measure and transfer 25 cm³ of L into apparatus B. The diagram shows apparatus A and B. This is apparatus A, and we have taken dilute sulfuric acid and put it into apparatus B. Number 1. Name apparatus A. Now we can see that apparatus A is pipette. 2. Name the other piece of apparatus that should be used with A to measure 25 cm³ of L. Now we can see that nothing is attached with apparatus A, so therefore something should be there to suck liquid. So we can use pipette filler or bulb. This will help apparatus A in filling with the given liquid, which is sulfuric acid aqueous. Three. Why is apparatus A used instead of measuring cylinder? This is because pipette is more accurate as compared to measuring cylinder, so we can write A is more accurate than measuring cylinder. B. The student makes a 25 cm³ sample of L to 500 cm³ with distilled water in apparatus B. This is solution M. Name apparatus B. As we know that sample of L is actually sulfuric acid aqueous, so therefore solution M should also be sulfuric acid aqueous with volume of 500 cm³. Name apparatus B. This is apparatus B. Now there are different names for this apparatus. We can write volumetric flask, standard flask, or graduated flask. Standard flask, or even graduated flask. The student transfers 25 cm³ of M into a conical flask and adds 2 drops of methyl orange indicator. Solution R is 0.1 mole per decimeter cube aqueous sodium hydroxide. R is put in a burette and run into the conical flask until the indicator changes color and the end point is reached. Now here we can see that solution M is actually sulfuric acid. While solution R is 0.1 mole per decimeter cube sodium hydroxide. See which liquid is used to wash out the burette immediately before it is filled with R. Now the experiment should be done like this, that first it should be washed with distilled water. And then with the same solution with which it is filled so that the concentration does not change. Now in this case we have R which is to be filled in burette, so therefore the solution should be washed immediately with R before experiment. D. What is the color change of methyl orange indicator at the end point? Now we can see that R is sodium hydroxide and it was put in the burette, while M is sulfuric acid and it was put in the conical flask. So as methyl orange was put in the conical flask, so it means that it was put in acid. So the color of methyl orange in acid is red, or you can also write pink. And when the solution is neutralized, it changes from red and pink to yellow, or you can also write orange. E. The student does 3 titrations. The diagram shows parts of the burette with the liquid levels at the beginning and at the end of each titration. This is titration 1, 2 and 3. Use the diagrams to complete the table. In order to take readings from these burette, you should always remember that you should move from top to bottom for reading. For example, this is 0. And the reading should be 0.0 initially, and then we have to move from top to bottom, that is 20 and then 20.5 and then 21. Then we can see that the meniscus is at this level, which is 21.2. You should also remember that the first value is initial burette reading, while the second value given is final burette reading. So in titration 1 we had 21.2 as final burette reading, so we can write 21.2. While the initial burette reading was 0.0, so we can write 0.0. Similarly for titration 2 we can take the values, just move from top to bottom. 22.1, 2, 3, 4, 5, 6, 7. So it is 22.7 as initial burette reading, and 43.5, 6, 7, 8, 9. So 43.9 as final burette reading. So we can write 43.9 and 22.7. Similarly for third one we can see 10.1 and then 10.2. The lower meniscus coincides with 10.2. Similarly from this portion we can see it is 30.5, 6, 7, 8. So it is 30.8. 30.8. So 30.8 is the final burette reading for third titration, while 10.2 is initial burette reading. Next is the volume of R in centimeter cube that is used. You can take this value by subtracting final with initial, so we have 21.2 as the volume of R in first titration. While subtracting these two, we have 21.2, and subtracting these two, the value is 20.6. Next is the best titration results. You should take the ones that are closer together, so we can see that these two are actually same, so we should tick these two. Use the ticked values to calculate the average volume of R. As we have two ticked values, so we can take the average by adding these two and dividing by 2. So the average is 21.2 centimeter cube. Part 2. Why was it unnecessary for the student to do a third titration? As we can see that in first two titrations the volume was exactly the same, so there was no need for doing the third one. So we can write first two results were same. Part F. Solution R is 0.1 mole per decimeter cube aqueous sodium hydroxide. Calculate the number of moles of sodium hydroxide in the average volume of 0.1 mole per decimeter cube sodium hydroxide used in the titration. Give your answer to 3 significant figures. The average volume was 21.2 cm cube that we got through the titration results. So the average volume is 21.2 cm cube, while the concentration given is 0.1 mole per decimeter cube. Now we can use the formula. Concentration in mole per decimeter cube is equal to number of moles divided by volume in decimeter cube. As the volume is in centimeter cube, so we can convert into decimeter cube by dividing by 1000. So it comes equal to 0.0212 decimeter cube. As we have to calculate the number of moles, so by rearranging this formula we can write moles is equal to concentration in mole per decimeter cube multiplied by volume in decimeter cube. Now we can put the values. Concentration is given, it is 0.100. Volume in decimeter cube is given, it is 0.0212. So the number of moles are 0.00212. And also we can see that in the answer we have 3 significant figures. G. Dilute sulfuric acid reacts with aqueous sodium hydroxide as shown. We have 1 mole of sulfuric acid that reacts with 2 moles of sodium hydroxide to form salt and water. Calculate the number of moles of sulfuric acid in 25 cm cube of M. From the balanced chemical equation we can write sulfuric acid ratio sodium hydroxide. So from balanced equation, for 1 mole of sulfuric acid we have 2 moles of sodium hydroxide. So for 0.00212 moles of sodium hydroxide, the number of moles of sulfuric acid can be found. We can cross multiply and the value of X will be 0.00212 divided by 2. So the number of moles of H2SO4 will be equal to 0.00106 moles. And this is in 25 centimeter cube of M. Part H. Calculate the number of moles of sulfuric acid in 500 centimeter cube of M. In the last calculation, we have found the number of moles in 25 centimeter cube. So we can write moles ratio volume. So for 0.00106, the volume was 25 centimeter cube. So for 500 centimeter cube, the moles will be X. Again, by cross multiplying, we can find the value of X. X equals to the value comes equal to 0.0212 moles. Part I. Calculate the number of moles of sulfuric acid in 25 centimeter cube of L. As in part B, we could see that 25 centimeter cube of L was used to make solution M, so it was only diluted, so the number of moles are not changed. Actually, the concentration is only changed. So the number of moles are similar, so it should be 0.0212. Part J. Calculate the concentration of sulfuric acid in L. Again, by using formula, concentration in mole per decimeter cube is equal to number of moles divided by volume in decimeter cube. By putting values, the number of moles are 0.0212 and the volume in decimeter cube is given to be 25 centimeter cube. So we can convert 25 centimeter cube into decimeter cube by dividing by 1000. So the concentration comes equal to 0.848 mole per decimeter cube. K. Between each titration, the student washes the conical flask with water and dries it. Number 1. A second student repeats the experiment but uses L instead of water to wash the conical flask and does not dry the flask. State and explain whether the second student titration volume of sodium hydroxide would be smaller or larger or unchanged compared with the first student's titration volume of sodium hydroxide. As we know that L is sulfuric acid, and the second student does not dry the flask, so it means that the volume of sulfuric acid will be more. So when more sulfuric acid is present, then more sodium hydroxide will be required to neutralize it. So we can say that the volume of sodium hydroxide would be larger. This is because more acid is present in the flask. Part 2. A third student repeats the experiment, washes the conical flask out with water but does not dry before each titration. State and explain whether the third student titration volume of sodium hydroxide would be smaller, larger, or unchanged compared with the first student titration volume of sodium hydroxide. Now we can see that the third student uses water, so water does not change the number of moles. So therefore the volume of sodium hydroxide would be the same or it is unchanged. So we can write question number 4. A student wants to electroplate a metallic spoon with a layer of copper. Plan how the student does the experiment. In the plan, you should follow these points. The first one is that state what needs to be done to the spoon before electrolysis. As the spoon is made up of metal, so the spoon must be cleaned before electrolysis in order to remove any impurities if there are present on the surface of spoon. So we can write clean or wash the spoon. You can also write use sandpaper in order to clean the spoon. In second point, they have mentioned to include a label diagram of the apparatus. Now for electroplating, we are going to take a container. It consists of an electrode of pure copper that is to be electroplated on the spoon. Second electrode is actually the spoon. Now both electrodes are connected to the terminals of battery, and you should remember that pure copper electrode must be connected with the positive terminal of battery to make it anode, and spoon should be connected with the negative terminal of battery to make it cathode. Now the electrolyte must be similar to the anode used. So the anode is of pure copper, so the electrolyte must be a copper salt. We can take copper sulfate. So this is CuSO4 aqueous. Now what will happen that copper atoms will dissolve in the solution to form copper ions, and copper ions will move to the spoon, gain electron from the spoon and are deposited on the surface of the spoon. So then after a while what will happen that spoon will be electroplated with copper. Third point is to give the names of the substances used. So we can write that we have taken anode of pure copper, cathode of spoon, and aqueous solution of copper salt, which is copper sulfate. Now this question has 5 marks in total. out of which 1 mark is for the first point, 1 mark is for the label diagram, and 3 marks are for the substances used. Question number 5. Compound Q contains 2 cations and 1 anion. The following table shows the tests a student does on compound Q. Complete the table. Identify any gases that are formed in the tests. So you have to complete the empty spaces and identify the gases if any is formed. Test A. Q is dissolved in water. The solution is divided into 2 portions for tests B and C. And the observation is that a colored solution is formed. Now we know that transition elements are those elements that form colored compounds. So we can conclude that Q contains ions of transition element. As it makes colored solution. B. To the first portion, aqueous sodium hydroxide is added until a change is seen. And the conclusion is that Q contains chromium plus 3 or iron plus 2 ions. Now we know that chromium plus 3 form green precipitate with aqueous sodium hydroxide. Iron plus 2 also forms green precipitate with aqueous sodium hydroxide. So the observation is green precipitate. Two, an excess of aqueous sodium hydroxide is added to the mixture from B part 1. And conclusion is that Q contains iron plus 2 ions. As we know that iron plus 2 ions form green precipitate with aqueous sodium hydroxide, but this precipitate is insoluble in excess. While the precipitate of chromium plus 3 is soluble. So we can write the observation that precipitate is insoluble in excess. Three, the mixture from B part 2 is warmed and gas formed is tested with damp red litmus paper. The gas turns damp red litmus paper blue. Now this test is for ammonium ions. And the gas that turns red litmus to blue is basic gas or basic in nature. So in conclusion, we can write that ammonium ions are present. And the gas that turns red litmus to blue is ammonia gas. So we can write ammonia gas is formed. Now moving to part C, you have to write the test and the observation for this conclusion. The conclusion says that Q contains sulfate ions. Now we know that the test for sulfate ions is that we should add dilute nitric acid. Then we should add barium nitrate. And what will happen that a precipitate of barium sulfate is formed. As barium sulfate is insoluble substance. So we can write the test as add aqueous barium nitrate, then add dilute nitric acid. The observation is the formation of white precipitate, so we can write white precipitate is formed. So we can see that in compound Q sulfate ions were present, and also we can see that iron plus 2 was present and ammonium ions were present. So as in the question they mentioned that Q contains 2 cations. So one was NH4 positive ammonium ion and second one was iron plus 2 and one anion, that was sulfate. Question 6. A student investigates the amount of heat released when ethanol burns. The diagram shows the apparatus the student uses. This is the apparatus. We have thermometer, metal beaker, 200 centimeter cube of water, and this is the ethanol that is burnt. A. The student burns a known mass of ethanol. The heat released is used to heat 200 centimeter cube of water. The student determines the temperature rise of the water while ethanol is burning. Number 1. In the first experiment, the student burns 1 gram of ethanol and the temperature rises by 20 degrees centigrade. State all the measurements the student makes to obtain these values. As in the experiment, the student burns 1 gram, so the student must know the initial mass and final mass. In order to find 1 gram, he will subtract final mass from the initial mass and then get 1 gram value. Second thing is the temperature rise. So this can also be obtained by measuring temperature changes from start to finish. So the student must know the temperature in the start and temperature at the end point or finishing. So there are 2 marks for this question. So we have 2 measurements, one is the mass and second is the temperature. We can write for mass, we can write mass of burner and contents at start and finish. Second is the measurement of temperature, so we can write temperature of water at start and finish. So it is the final temperature minus initial temperature. So the student gets 20 degrees centigrade. And final mass minus initial mass, he gets 1 grams. Part 2. Why is a metal beaker used instead of a glass beaker? As the student is measuring the amount of heat released by ethanol, so in order to get maximum amount of heat, he should use metal beaker instead of glass beaker because metal is a better conductor. Part 3. The student finds out that 1 gram of ethanol should give a theoretical temperature rise of more than 20 degrees centigrade. Suggest 2 reasons why the temperature rise of the water was less than the theoretical value. As in the diagram, we can see that this space is open, so the heat can be lost to the surroundings, and also we know that ethanol is volatile in nature. So the ethanol must have evaporated before the start of experiment. So we can write heat loss or energy is lost to the surrounding. And we can also mention the evaporation of ethanol, that ethanol can evaporate. Part 4 suggests 2 ways using 1 gram of ethanol and 200 centimeter cube of water in which the apparatus can be changed to produce a temperature rise of more than 20 degrees centigrade. Now looking back at the apparatus, we can see that the container is open, so heat can be lost to the surroundings from here. And we can also see that there is a distance between the flame and the container, so this distance could be reduced in order to minimize the loss. So what the student should do is that he should cover this apparatus and he should reduce the distance between the flame and the container. So we can write use lid, or you can also write close the can. Second point is to reduce the distance between the flame and metal container. B. The relative formula mass of ethanol is 46. The formula is C2H5OH. Calculate the number of moles of ethanol in 1 grams. This is a simple question, as we know that number of moles is equal to mass in grams divided by molecular mass. So putting values, mass in grams is 1 gram and molecular mass is given, which is 46. So therefore the answer is 0.022 moles. Moving towards part C, the experiment is repeated using the same number of moles of different alcohols. The temperature rises are shown in the table. We can see we have number of carbon atoms in each alcohol molecule. So we have 2 carbon alcohol, 3 carbon alcohol, 4 carbon and so on. And the temperature rise is also given in degrees centigrade. So we have 20 degrees centigrade for 2 carbon alcohol, 32 for 3 carbon and so on. Part 1. What evidence in the table shows that all reactions are exothermic? Now exo means outside and therm means heat. So exothermic reactions are those reactions in which heat is released to the surroundings. From the table we can see that temperature rise is positive for all the chemical reactions. So it means that all the chemical reactions are exothermic in nature. So we can write temperature rise. Is positive. Part 2. Plot the data in the table on the grid. Draw a straight line of best fit. Extend your line to the left hand side of the grid. In the graph we can see that on y-axis we have temperature rise, so we can obtain the temperature rise from the above table. On x-axis we have number of carbon atoms in each alcohol molecule, so we can also follow the carbon atoms. In the table you can see that for 2 carbon atoms we had 20 degrees centigrade temperature rise. So this is the point that is obtained. For 3 carbon atoms, the temperature rise is 32 degrees centigrade. As on y-axis, we know that each division consists of 2 degrees centigrade. So 20, 22, 24, 26, 28 and 30. This is for 30 degrees centigrade temperature. So for 32, we can draw the point over here. Similarly, for 4 carbon atoms, the temperature rise is 43 degrees centigrade. So the first small box is for 42, and then we can draw in the middle. So it becomes 43 degrees centigrade rise. For 5 carbon atoms, the temperature rise is 55. So in the middle, we have 50. And then this is 55. For 6 carbon atoms, the temperature rise is 66. So we can move to the third box. This is 66 degrees centigrade temperature rise. For 7 carbon atoms, the temperature rise is 78. So it comes at this point. Now we have plotted all the points and we have to draw a straight line of best fit. Now we have drawn the line. As we can see that it connects all the points. And we also have extended the line to the left so that it touches this temperature rise. Moving towards part D, the student repeats the experiment with methanol. The student uses the same number of moles of methanol as the other alcohols and the same volume of water. Use your graph to predict the temperature rise for methanol. As we can see that methanol consists of 1 carbon atom. So from graph we can find the temperature rise for 1 carbon. As on x-axis we had number of carbon atoms, so this is 1 carbon, and for 1 carbon atom this is the temperature rise. And it is about 9 degrees centigrade. So we can write 9 degrees centigrade. Part E, the student predicts that the temperature rise with another alcohol is 90 degrees centigrade. The student uses an initial water temperature of 20 degrees centigrade. Explain why it is not possible to obtain a temperature rise of 90 degrees centigrade. As the initial temperature was 20 degrees centigrade and rise was 90 degrees centigrade, so the total temperature rise must be 20 plus 90, which becomes 110 degrees centigrade. Now as the solution was made up of water, the boiling point of water is 100 degrees centigrade, so therefore it is not possible to obtain a temperature rise of 110. So we can write that temperature goes above boiling point of water. Part 2, the student wants to obtain a temperature rise of 90 degrees centigrade with this alcohol and the same apparatus. Suggest one way the student can obtain a temperature rise of 90 degrees centigrade. Now this can be done if the total temperature rise is less than 100 degrees centigrade, because at 100 degrees centigrade water starts to boil. So the student can take any temperature below 10 degrees centigrade. For example, 8 degrees centigrade or 7 or 6. So the total temperature should be below 100. So we can write starting temperature should be less than 10.
Thank you for watching. Don't forget to like, subscribe and share. Stay tuned for more upcoming videos. Stay happy. Take care.